In section 3.1, we're going to talk about forces some more. So a force is a push or a pull, and it has to happen between two objects. So like if the Earth pulls on the sun, and like you have the Earth and you have the sun. If you push on the wall, you have you and the wall. And we'll come back to that a bit more when we talk about Newton's third law. A force is a vector quantity, so it needs a direction. So if you talk about the force of gravity pulling on me, it would have a certain amount and it would need a direction. So maybe 800 newtons downwards. And the SI unit is newtons. But sometimes we might just talk in pounds just because you're going to be more familiar with pounds. And just like before we could do a conversion from feet to meters, we could do a conversion from pounds to newtons. If an object feels an unbalanced force, which we're going to call a net force, then it will accelerate in that direction. So for example, right now, think of your body. And right now, gravity is pulling down on your body. But you're not actually falling. You're not accelerating. And so what that means is actually there is no unbalanced force on you. So gravity isn't the only force acting on you. The chair is supporting you from falling. And those balance each other out, kind of cancel each other out. Let's do another example. I have a block sliding across a floor. And we're going to talk about the forces acting on this block. So we've got gravity pulling downward on the block. And I can draw a little arrow indicating that the floor is supporting it upwards. So these two basically are going to cancel each other out. And maybe this block is already sliding to the right because somebody had pushed it a while ago. And while it's sliding to the right, it feels friction. And friction is going to be due to the floor and act backwards on it, trying to slow it down. So for this one box, we could say that there are three forces acting on it. Gravity down, a support force up, and friction backwards. When you imagine a block sitting on a floor or you sitting on a chair and you're stable, the upwards and downward forces perfectly cancel out, which seems a little odd. Like, how does it know how to do it perfectly? Basically, the support force from an object, like you sitting on a chair or you pushing on a wall, right? It has a limit. And so it will be able to support a certain amount of force up until a limit, and that's when you break the wall or the chair breaks. So the supporting force from pushing on an object will perfectly match it. It will adjust up until the object breaks. Now, so we've identified the three forces that were acting on the block. Now let's imagine their net, like which ones are unbalanced. So we talked about how these two will perfectly balance and cancel out. So as far as the block is concerned, it doesn't really notice either of them. The forces are canceled out. The only force that isn't canceled out is this backward friction force. And so that backward friction force is going to be the unbalanced force, or you could also call it the net force. But this is then going to cause an acceleration. And since it is a backwards force, then the acceleration will be backwards. And the velocity was forwards. And if the velocity and acceleration are opposite, the box will slow. Section 2 is Newton's first law. So my phrasing of Newton's first law is going to be an object with no unbalanced net forces acting on it will move with constant velocity. So basically, if all of the forces are balanced on a block, it will move with constant speed and it cannot turn. Because changing your speed or turning is an acceleration, and an acceleration needs an unbalanced force. A lot of times people will just restate this as an object in motion will remain in motion and an object at rest will remain at rest until an unbalanced force acts on it. A term your book introduces is inertia. And inertia just means that objects with more inertia resist changes to their velocity more. But really, you can go ahead and interchange the word inertia and mass. Mass is the property that we measure to talk about inertia. So if you were to imagine a full semi-truck, a full semi-truck is very massive, and so it will resist changes to its velocity, which basically means you need more force to get it to go. You would also need more force to get it to stop, and you would need more force to get it to turn. So massive objects need more force to change their velocity.